For our preliminary example in this section, I would like to sketch the vector field. Capital F of xy is equal to the vector x comma negative y. Now, when it comes to sketching a vector field such as this one, usually getting a good idea of what's going on at the origin, on each axis, and within each of the quadrants is going to be advisable. So what we're going to do is select 9 different points. 9 different points will be the origin, the positive and negative side of each axis, and 1 point within each quadrant. My recommendation is going to be to simply let x and y be all of the integers from -1 up through +1. So if we go as one would read, left to right and top to bottom, these points would be -1, 1, 0, 1, 1, 1, -1, 0, 0, 0, 1, 0, -1, -1, 0, -1, and 1, -1. The corresponding vector that we're supposed to get, the first component is going to be the same as the x-coordinate, and the second component will be the negative of the y-coordinate. So what I'm going to do is have us go down the line, deal with all of the y components first, and then come back for the x components. This does become a little bit cumbersome to try to draw all of this in here, but it'll be well worth it. So, as I mentioned just a moment ago, I'm going to start with the y coordinates. I'm going to be taking each y coordinate, and the y component is going to be the negative of the y coordinate. So for the first 3 points, the y coordinate is +1. These will all become -1. In the next 3 points, all of the y coordinates are 0. When I plug them in here, I'm going to get -0. -0, though, just the same as 0. And then for the last 3 points, if I negate each of these for this component, each of these -1s will become +1. Now, additionally up here, the first component of the vector is supposed to be the same as the x-coordinate. So for -1, 0, and 1, that'll be -1, 0, and 1. In fact, that'll repeat all the way down here. So -1, 0, 1, -1, 0, 1. So here's the deal. At each of these points, these will be the initial point of each of these vectors. So for example, at the ordered pair -1, 1, upper left, the corresponding vector is going to be -1, -1. That points in the negative x direction and the negative y direction. So approximately like this. At the ordered pair 0, 1, here, corresponding vector is 0, -1. So that'll point in the downward direction. Then at the ordered pair 1, 1, the corresponding vector is 1, -1. That'll be +x, -y. So +x, -y means to the right and down. If we repeat the process with all of these points and vectors for the next 3, they all have a vertical component of 0, so they'll all be horizontal. And for the last 3 points at -1, -1, we're pointing left and up. For this one, we're pointing just up. And for the last point, we're pointing right and up. Now, what this does is it'll give us an idea of, if we were to start with a point within the plane, in which direction is this going to be pushed. So for example, if I were to start up here in quadrant number 1, this lets me know that I'm going to be pushed to the right and down. So something along these lines. The closer that we get to the x-axis, the smaller the component becomes, so we will see some sort of asymptotic behavior. Additionally, we could figure this out for all 4 of our quadrants, and will sort of be pushing us in the directions that are indicated. Now, something else that you might notice is that if you start with a point that is directly on top of an axis, if it's directly on top of an axis, it will simply stay on that axis. So if we're on the y-axis, this vector field will push us back toward the origin. And if we start on the y-axis, this will push us back toward the origin. And if we start on the x-axis, it'll push us away from the origin. Now, the slightest little deviation of being pushed off of the y-axis means that we're going to wind up very far away from the y-axis. It is in that regard that the y-axis could be referred to, in this case, as being unstable. Whereas if we start on the x-axis, if we were to deviate ever so slightly from the x-axis, this vector field would be pushing us back toward the x-axis. So in that regard, this is referred to as a stable axis. So more on that in differential equations.